Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. First, we will interface the LCD with microcontroller. As we can see that LCD is directly connected to port B of microcontroller. Here we can find pin number 1 is ground, which we have already connected in our Vero board. Pin number 2 is 5 volt and we have already connected 5 volt with the LCD. Pin number 3 is V0 and pin number 4, that is RS, and RS will be connected to RB4. Pin number 5, that is RW, will be connected to ground. Pin number 6 will be connected to RB5. Then we'll connect pin number 11, that is D4, with RB0. Pin number 12, D5 with RB1. Pin number 13, D6, RB2. Pin number 14, D7 with RB3, and we'll connect pin number 15 with 5 volt, and pin number 15 is anode of backlight, and we'll connect pin number 16 with ground, and pin number 16 is cathode of backlight. As we can see from the help of microC compiler that we can connect a LCD with microcontroller using only 6 pins, and these 6 pins are RS, enable, and D4 to D7. As we can see from this diagram that RB0 is connected to D4 of this LCD, RB1 is with D5, RB2 is with D6, and RB3 is with D7. And here we can see that RB4 is connected to RS pin of LCD and RB5 is connected to enable of this LCD. Here we can see a 10K variable resistor is connected on V0, that is contrast pin for LCD, and one end of resistor is connected to ground and second end is connected to VCC, that is 5 volt. So we'll connect the LCD with microcontroller using these connections. Now we will interface the LCD with port B of microcontroller. We have already connected the ground and 5 volt connection to the LCD. Now we'll connect a 10K resistor with pin number 3, that is V0 of LCD. Here I will connect a multi-turn variable resistor of 10K to connect with the contrast pin, that is V0, pin number 3 of LCD. Now I will connect one end of this variable resistor with 5 volt, second end with ground, and the center pin, that is a variable pin of this variable resistor, will be connected to pin number 3 of this LCD connector. Here we can find that all these 3 pins of power supply jumpers are connected with 5 volt. So I will apply 5 volt from these connectors to the variable resistor. We have connected 5 volt to the variable resistor using this jumper connection. Now we'll connect the third pin of this variable resistor with ground, and here we can find we have ground on pin number 1 of this programming connector. So we'll connect the variable resistor with this pin. Here we have connected third pin of variable resistor to the ground. Now we'll connect the center pin of this variable resistor to pin number 3 of LCD connector. Here we have developed a route to connect middle pin of this variable resistor to pin number 3 of LCD connector. We have connected pin number 3, that is V0 for the LCD, to a variable resistor of 10K. Now we'll connect pin number 4 of LCD with RB4. RB7, RB6, RB5, RB4. Now we'll connect pin number 5 of LCD, that is RW, to the ground. And here we have pin number 1 of LCD, which is connected to ground. Now we'll connect pin number 5 of the LCD to the ground pin, that is pin number 1. We have connected pin number 5 of LCD to the ground. Now we'll interface other connections of this LCD to the microcontroller. Now we'll connect pin number 6, that is enable pin for LCD, to RB5 of microcontroller. Now we'll connect pin number 7, pin number 8, pin number 9, pin number 10 of LCD to the ground, and these pins are D0, D1, D2 and D3. Here we have connected pin number 7, pin number 8, pin number 9 and pin number 10 of LCD to the ground. Now we'll connect pin number 11 to RB0, pin number 12 to RB1, pin number 13 to RB2 and pin number 14 to RB3 of microcontroller. We have connected pin number 11, pin number 12, pin number 13 and pin number 14 of LCD, that is port RB0, RB1, RB2 and RB3. Now we'll connect pin number 15 of LCD with 5V and pin number 16 with ground. We can see from the drawing that pin number 2 of LCD is connected with 5V. Now we'll connect pin number 2 with pin number 15. Now we'll connect pin number 16 of LCD with ground. We have developed the required interface for LCD display. Now we'll check the continuity of all these connections with microcontroller. We'll also perform a short circuit test for power supply and ground connection. First, I'll perform a short circuit test between power supply and ground connection. Okay, there is no short circuit between power supply and ground. Now we'll check the connection for LCD. Pin number 1 of LCD is connected with ground. Okay. Pin number 2 of LCD display is connected with 5V. Here we have connected pin number 2 of LCD display with power supply jumper on pin number 3. Okay, pin number 2 of LCD display is connected to the power supply jumper pin number 3. Pin number 3, that is V0 of the LCD, is connected to the center point of this variable resistor. Okay, pin number 3 of LCD is connected to the center point of the variable. Pin number 4 of the LCD is connected to the port RB4 of the microcontroller. RB7, RB5, RB6, RB4. Okay, pin number 4 is connected to RB4. Pin number 5 is connected to ground. Okay, pin number 5 is ground. Pin number 6 of LCD is connected to port RB5 of microcontroller. Pin number 7, 8, 9 and 10 of LCD are ground. That is 7, 8, 9 and 10. Pin number 11 is connected to RB0 of microcontroller. Okay, pin number 11 is connected to RB0. Pin number 12 of LCD is connected to RB1 of microcontroller. Pin number 13. Pin number 13 is connected to RB2. Okay, pin number 13 is connected to port RB2 of microcontroller. Pin number 14 is connected to RB3. Okay, pin number 14 of LCD is connected to port RB3 of microcontroller. Now we'll check the connections for pin number 15 and 16. Pin number 15 is 5 volt. And pin number 16 is ground. We have completed the interface for LCD display with microcontroller. Now we'll connect ULN2803 Darlington driver with port B of microcontroller. Here we can check pin number 1 of ULN2803 is connected to RB7, which is pin number 40 of microcontroller. We have connected all 8 inputs of ULN2803 Darlington driver with microcontroller. We have already completed the interface for LCD display and we have completed the interface for ULN2803 Darlington driver with microcontroller. Now we check the continuity of port B of microcontroller with ULN2803. Pin number 1 of ULN2803 is connected to pin number 40 of microcontroller. Pin number 2, pin number 3, 4, 5, 6, 7 and 8. Pin number 9 of ULN2803 Darlington driver is connected to ground. Okay, now we'll connect pin number 10 of ULN2803 Darlington driver with 12 volt. We will place a bridge here. Here we have placed a wire bridge. We will place another wire bridge here. We have placed 2 wire bridges here to provide 12 volt connection for pin number 10 of ULN2803. Now we'll check the continuity of pin number 10 of UL2803 with 12 volt. Okay, pin number 10 of UL2803 is connected with 12 volt. Now again we'll perform a short circuit test for 12 volt and ground. Okay, there is no short circuit between 12 volt and ground connection of power supply. We have completed the interface for LCD and UL2803 Darlington driver. Now we can insert the IC of UL2803 Darlington driver in this base. Please take care the pin number 1 of this IC. Pin number 1 is on left hand side. Here we can find a notch on IC and a dot on pin number 1 of UL2803 Darlington driver. Now we'll write a program for 8 LEDs. First we'll write a program for blink of all 8 LEDs simultaneously, and these LEDs will blink with the delay of 0.5 second, that is 0.5 second on and 0.5 second off. Then we'll write a program of counter to run on these 8 LEDs.